Hi, so in this video, we're going to look at conic sections, and we're just going to basically answer questions that are related to the ellipse. Okay, so the statement that we have says find the foci, vertices, and hence sketch the ellipse. So we're going to be having a good number of questions here that are pretty interesting. So the first one that we have is let's say you are given uh, x squared over 4 plus y squared over 9 is equals to 1. So here we have to find the foci. Remember to say according to the how we observe this equation, it's obvious the ellipse that we have is centered at the origin, which is simply 0 comma 0. So we can simply say the origin, um, which is C, where the center is simply 0 comma 0, as we know already. Okay, so we're looking for the foci, of which we know to say looking at the way it is here. But again, before we continue, it's important that we determine whether A is greater than B, or maybe B is greater than A. Okay, so according to my observation here, it's obvious. Like here, my A squared is equals to what? Is equals to 4, and my B squared is equals to what? Is equals to 9. So my B is greater than what? Is greater than my A. So this one is along the what? This one is along the y-axis. Okay, so here we are simply going to say our foci is simply going to be 0, comma, positive or negative, C, and we are supposed to get our C from our A and B there. So to get our C, we're going to say our C squared is going to be equals to B squared minus A squared. So here what we have, our B squared is a 9, okay, minus our 4 squared, which is sorry, our A squared, which is a 4, giving us a 5. So C squared is equals to what? Is equals to 5. Then it simply means our C is equals to positive or negative the square root of what? Square root of 5. So our focus, or which we indicate as our foci, is 0 comma positive or negative square root of what? Square root of 5, like that. That's our foci there. Okay, so I can indicate to say I've now determined what my foci is. So I'll say foci here, it's 0 comma positive or negative the square root of what? Square root of 5. When you say foci, it has, because like the ellipse has two there's two focus, or I don't know how you'd call them. Like there's f1 and f2, so all together we'd call them as foci. So that's what we get right there. So also have to determine the vertices. So in that case, the vertices as well, like I'll just say v, they're supposed to be 0 comma positive or negative, positive or negative A initially, but because it's along the y-axis, I'm going to say B here. Okay, so we're going to say 0 comma positive or negative. We know that our B squared is 9, so meaning our B is equals to 3, because you're saying B squared is equals to 9, meaning B is equals to positive or negative what? Negative 3 there. That's how that 3 is coming about. So for the vertices, you have 0 comma positive or negative 3. So remember here for the foci you have f1, which you can indicate to say f1 is going to be, let's say, 0 comma square root of what? 5. Then you can indicate your f2 as 0 comma negative square root of 5, like that. So that is the same for the vertices as well. Like you are going to have two v1, you are going to have two of them. You are going to have v1 and v2. So having now indicated or found our foci and the vertices, we can now go ahead and do the sketching. Okay, so here we now say this is along the y-axis. Okay, so that is the meaning the y-axis is our is the prime axis in this case. Okay, so we have our y-axis and we have our x-axis. It's very important that you indicate so as to, like, when someone is marking your script or something, whether it's a test, a quiz, or something, it's going to be at least going to be the work is going to be neat. All right. So I believe something else that you have to find as well is the core vertices. So the core vertices are just indicated by CV as opposed to B. here we're going to say a, not really a, but positive or negative a, comma what, comma 0. Okay, and we know to say our a squared is equals to 4. So meaning our a is equals to what? Positive or negative 2. Okay, positive or negative 2. So I can say positive or negative 2 comma 0. So what it means is that if, let's say this is my 1 here and I have a 2 there, negative 1, negative 2 here, so I can have negative 2 and positive 2 there. Those are my core vertices. Then for my vertices, I can like have 1, 2, 3 there, then negative 1, negative 2, let's say negative 3 there. Okay, then something like that. So for the focus we say is the square root of um, the square root of the square root of 5, which can be, because the square root of 4 is 2, so it can be above 2. So maybe it would be somewhere at that point. I'm not really having a calculator with me here. Okay, all right, yeah, anyway, it's something like that. So it can be somewhere there, or we know that it's above 2, and that's where we're going to have our focus. So I can indicate to say here I have my f, let's say f1 here, then here I can have my f2 there, like that. Okay, so remember to say for the vertices, this is our v1. Okay, let me just indicate the bottom one as v1, then the top one as our v2. Then this is our core vertices, which I can just indicate as cv1, then here I can get cv2. Okay, so though like sometimes people don't really pay attention to the core vertices, they usually pay attention to just the vertices and the focus. All right, but yeah, myself, I prefer to pay attention to all of them, because when I'm graphing the ellipse itself, at least I have that kind of neatness as I'm drawing the ellipse. Okay, so we're going to start from 2 there, oh my god, up to 3 there, which is our focus, I mean the vertex. Then we go back to 2 here, and of course when you're using your own pencil or something, this is going to be much better compared to my drawing. Yeah, so that's how the graph is going to be oriented. So that's basically how you answer that question. Let's look at another one. um, let's say we're given uh, let's say we're given 16x squared plus 25y squared is equals to 400. Okay, 400. I believe for this one I will need to use a calculator. Yeah, I don't want to start guessing, so let me try to find my calculator. It's somewhere here. Okay, yeah, I got it. So the first thing, of course, we have to find the foci, but before we do that, we have to write the standard form. That's very important. You should always remember to write the standard form. So what we do is that you're going to divide, uh, or in this, or if you don't want to say it like that, you can just do this. Then I multiply it by what? By 1 over 400. Okay, so this now is going to give me something like 16, sorry, this is going to give me x squared divide by, so now the thing is, how many times does 16 go into 400, which I believe is 25. Yes, yeah, it's 25. So that's 25 there, plus, so y squared divided by, here it was like 25 divided by 400, which is 16. Okay, so this is equals to 1. So now to can now go ahead and find what the question is asking us to find. So here we have to find the foci. So we observe to say here our a squared is equals to 25 and our b squared is equals to 16. So we can determine our c squared by saying c squared is equals to a squared, uh, a squared, which is 25, minus b squared, which is 16, giving us a 9 there. Okay, so remember our foci, in this case, you observe to say your a is greater than your b. So the fact that your a is greater than your b, meaning the ellipse is along the, like it's oriented on the x-axis. Okay, so that's how myself, like I easily just, when I just look at the equation, I'm able to tell on which axis is it, and like that makes it very simple for me to really answer the question because I know where I'm going. All right. Okay. So now in this case, having determined that, we can say, or we can say the foci, which I'm just going to indicate as F there, is going to be it's going to be positive or negative c comma what, comma 0. And again, we also observe to say this um, this is centered at the origin, which is 0 comma 0. So the center is 0 comma 0, where you have your h being equals to 0 and your k being equals to 0. So in this case, you have to determine what your c is. So if our c squared is 9, so meaning c is positive or negative 3. So I can just substitute the 3 there. Then what about the vertices? I'll just indicate using v. So this is going to be positive or negative a comma 0. Okay, now the question is, what is our a? Okay, so if you have our a squared being 25, meaning your a is what, 5, which is just a square root of 5 of 25. So you have your vertices there. For the core vertices, I would love to indicate them as well. Core vertices, the core vertices, so it's just thing whereby if you have your vertices along the y-axis, meaning your core vertices are going to be on the x-axis. Then if it's like it's vice versa, now we have our vertices on the x-axis, meaning our core vertices are going to be on the y-axis, unlike the previous question that we did. All right, so now let's look at uh, hmm, these are going to be on the y-axis. Yeah, so I mean you're going to have 0 comma positive or negative b, and we have our b squared to be 16, so meaning our b is a 4 there. Then what else do we need to find that might be necessarily? Nothing. I guess we have all the data that we need. Okay, let's go ahead and sketch this one. uh, okay, we have our y-axis there, and make it a bit longer. So some questions, you're also able to determine the eccentricity as well, which I believe, if you remember, we said the eccentricity is just it's just more like a property that describes how oval the ellipse is, like whether it's too big on the center or not, like the more like the, if it was a circle, I'd call it the diameter or something. I'll try to show as we sketch this one. Okay, so uh, for the vertices, we have one at negative 5 and another one at positive 5. So let's say you have like 1, 2, 3, 4, 5, which is a negative there. Then we have another like 1, 2, 3, 4, 5. Okay, so I have 5 here, I have negative 5. Then for the core vertices, I have like 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4 here. Okay, negative 4. Maybe that has gone too far. I don't want it to look like a circle. So let me try to reduce the units for, okay, maybe something like that. That's a bit better. Okay, so that'd be negative 4 and positive 4 there. So for the focus we have 1 at negative 3 and positive 3. So we have one here at negative 3, and we have another one here at positive what? Positive 3. So you can indicate to say here this is your f1 and this is your what? Your f2. For the vertices, I can say this is my v1, this is my v2. Okay, so here I can have like my cv1, then here I can have my cv2, core vertex 2 and core vertex 1. So we can go ahead and do the sketching, which will start, of course, start from the vertex there, passing on the core vertex there, and you go down like that. And as I said, when you're using pencil, this would be much better compared to what I'm doing right now. But of course, this is just to give us a picture of how it's really going to look like. Okay, there we have it. So remember, I was talking about eccentricity. So eccentricity is just a property that describes the ovalness of a conic section. So it's like here when you look at it on the center here, there are some ellipses whereby like they appear to be more like that, and there are some like they are so slim on the center. It's like, remember, concave lens, the convex lens, the way describe the, like the way differentiate them looking at the center. So it's like if you look at this, it's a bit smaller on the center there, and this one is a bit bigger. So the value of the eccentricity is the one that describes that. And of course this question is not really asking us to find the eccentricity, but if we were to find, we would just say eccentricity is equals to a of what, not really a here, is it a, um the equation is pretty simple. It's supposed to be c over a. Okay, so this is for this one, but if like for the first question y is oriented on the y-axis, y-axis, I would have said y is equals to c over b, like that. And that's how you answer that question. Let's look at something a bit different, but of course we're still talking about an ellipse. Okay, I'm trying to really exhaust questions on an ellipse that are centered at the origin, that are written in different forms. Okay, so this one is a bit similar to the one that we are from doing, but we'll do it anyway. So it's like we have, let's say you're given 2x squared plus y squared is equals to 4. So you do the same here. We're going to multiply both sides by 1 over 4, of which you're going to get something like x squared over 2 plus y squared over 1, which is not 1 but 4, is equals to 1, like that. Okay, so we say 2x squared divided by 4, 2 there, yeah, just like that. So we really have to understand the how the standard equation of any conic is supposed to be, so that if you are given in any other form, maybe it's given in like in the general form, you're able to bring it back to the standard form, because for you to determine everything else, it has to be in the standard form. So in this case, determine the foci. So first things first, despite this conic or the ellipse being uh, centered at the origin, one thing that you're able to observe for me is that since I don't really like confusing myself with b and a, I'll just say, okay, this is my a squared and this is my b squared. And the first thing that I observe is that my a squared, or a itself, let me just say a is smaller than what? Is smaller than my b. And I know to say my a squared is equals to 2, my b squared is equals to what? 4. So meaning my c squared is going to be equals to b squared minus a squared, which is simply going to be what? A 2. Is it a 2? Yeah, it's a 2. So meaning the foci here is supposed to be 0 comma positive or negative c, and what's our c is the square root of what? Square root of 2. Then what about the vertice? The vertices are supposed to be on the y-axis as well, which is going to be 0 comma positive or negative a, and our a is what? Mm, our a is the square root of 2. Okay, uh, is it really? No. It's supposed to use b, so it's supposed to be just 2 there, because you're supposed to say b is in the, if our b squared is equals to 4, meaning our b is equals to 2. Yeah, so I almost made the mistake there. Almost. I had made a mistake, but I realized it anyway. Yeah, so the core vertices is supposed to be on the x-axis, so meaning you're going to have positive or negative a, which is the square root of 2 comma 0. Okay, so now let's do the sketching. We know it's on the y-axis, like that. Okay, so we can as well indicate this is our y-axis and this is our x-axis. So our core vertices, um, if this is 1, if this is 2, 1, 2 here, like that. So the square root of 2 is 1.414213562, and it keeps on going, which might be somewhere here. like at these points here. That's where we're going to have maybe our core vertices there. Then um, our vertices, they are at 2. So like we can have one, let me make it a bit bigger. So we have one, let's say we have 2 there, 1 and 2, like that. So we can have our focus, one at this point and another one at that point there. Okay, so we can do the sketching now. Okay, so from this core vertex to that vertex there, from that vertex to this one, and what am I doing, from this one to this one, and like that. And that is our what, that is our ellipse uh, for that equation there. Okay, so now let's look at the last example in this video, which is pretty interesting. Okay, so this one, let's say you're given x squared plus y squared is equals to 1. Okay, so one thing that you observe here is that of course this is an ellipse, but here, like here is supposed to have like divide by 1, divide by 1, which you already have, but you don't even have to show it anywhere. So this can be like a squared is equals to 1, b squared is equals to 1, and c squared is supposed to be b squared minus a squared, or a squared minus b squared, of which the value of b and the value of a just like it just tells us in terms of like it just indicates the orientation of that ellipse. But in this case, a and b are the same, so meaning your c squared is going to be 0, which will make your c to be also be what, to be 0, meaning for this one you don't have a foci, like there's no focus. Okay, and of course you know the center is 0 comma 0. Okay, so this is a special type of conic section. I mean, this is a special type of an ellipse. It's an ellipse, but it's a special kind of an ellipse. And if you have watched the previous videos, you will understand that this is simply a what, this is simply a circle. That is a circle whose radius is equals to what, is equals to 1. Okay, yeah, so the radius of that one is equals to 1, because remember we say the circle has the equation x squared is equals to, no, no, not x squared, but let me say x squared plus y squared is equals to uh, r squared. And in this case our radius is equals to 1, because we are saying r squared is equals to 1 is same as r being equals to what, being equals to 1 as well. So we have a radius of what, radius of 1. So here is just a matter of us sketching the circle of radius 1. So let me try to draw and the xy plane like that. Okay, so I guess I can try to use a compass for this one, so that at least this would be a bit better. Okay, I can pin it at that point. Okay, I can take that as my radius. Okay, but we are going to assume that's a 1, so I'm just going to, so it will be something like that, and that's our circle. Okay, so that's how we answer those questions on the ellipse. When the question is asking you to find the foci, the vertices, and sketching the ellipse is pretty straightforward. You just first of all have to observe like what's the center. Secondly, what's the orientation? Is it on the y-axis or is it on the x-axis? And you can easily observe those from the value of a and b. And I cannot overemphasize this. If you have your x squared plus your y squared is equals to 1, and remember to say this is supposed to be a squared divided by, I mean we have b squared there. So don't really I have seen people who swap them. I tried to use that method of swapping them whereby I say, oh, okay, here if my b is greater than my a, meaning I'm going to write it as like I'll replace here, then here I'll put b squared, then here I put what, a squared. That works, but for me, I feel like I'm kind of like cheating, because in the first place I was telling myself this is a and this is b, so I just have to take it like that, as someone would say gospel truth. Yeah, but it works anyway, even if we call it gospel truth. So my B is greater than my A. If my B is greater than my A, meaning I'm oriented on the y axis. If my A is greater than my B, meaning I'm oriented on the x axis. So the knowing the orientation of the conic section, like of the regardless whether it's an ellipse, parabola, hyperbola, so on and so forth. I can't say circle because like the circle you can't really, it just looks the same unless you put it in 3D maybe. Yeah, so knowing the orientation is very, very, very important. Know the orientation first before you even start doing anything. Okay, if you are able to observe if you're able to see, okay, this is oriented on such and such an axis before you even do anything, then I like, believe me, you will never feel any question that requires you to sketch any coding section that will be involved. So that's how we go about this. Thank you very much for watching.